Hello, it's Rob Fell with Iris Factory Automation, and today we're talking about one of my most favorite of all topics, which is machine vision. So stay tuned, we're going to talk about some of the most important things about deploying a good machine vision application. So, all right, McKenna, what's number one?
Number one is how to qualify a good application.
Got it. So how to qualify a good vision application. So, you would think about, first of all, how are you doing it today? And maybe you're not even doing it today, but I think the key to a good vision application is that you can get to a non-subjective requirements document. So that's fundamental to really good vision deployments, is having a good requirements document and making sure that you have internal agreement on that requirements document. So we'll see applications bubble up in quality or bubble up in production or whatever it may be, and once you start to involve other parts of the business, you get kind of warring factions because you're constantly balancing what's a non-conforming product versus what's a good product versus getting production off the line and balancing scrap and all these things. So the best way to start is to have a great written requirements document so you can get a fundamental understanding of what you all internally agree to is a fault condition, and then how you can convey that to your integration or machine vision parts provider. What's next?
Next is thinking about your environment with vision.
Super important. So, machine vision, different than some other automation competencies, is really, really environmentally dependent. Environment, not only being traditional things like, is it washed down or is it refrigerated, but, what does the natural light condition look like, and what are the lighting conditions in the machine look like, and making sure that you take all those things into account so you design a good mechanically sound system that insulates you from the environmental restrictions that you have. So and also don't try to home grow something. I mean, if you're in a wash down environment, there's companies who make really good wash down camera enclosures. APG Vision, for example, is who we use, and they make a great set of wash down enclosures. So don't go out and try to home grow something. Buy wash down enclosures, buy wash down vision lights, and don't try to do it yourself. But always be aware of the environmental challenges that may come about in your application, and get those documented in that requirements document that we talked about a few minutes ago. Number three.
Number three is how to develop a scope of work.
Scope of work. Okay, so when you think about a scope of work, think of it in the context of how you would develop a scope of work for general applications. But you want to make sure that, essentially, as I said kind of in topic one, is you want to iron out the subjectivity. So you want to make sure that you get internal alignment on conforming and non-conforming. I think you also have to have some agreement as what's acceptable in terms of scrap. You want to make sure that you have a really well-defined success criteria as far as how many parts do you want to see to be able to say, okay, this is working and it's not creating too much scrap. So having a good solid end game is really important. And then, fundamentally documenting all those things and then sharing it with your vendor, your integration partner, and making sure that you have buy-in between the two parties as to what the requirements are. And then use that as a baseline, for success moving forward. So eliminate your subjectivity, get everything in writing, speed, location, environment, any extraneous factors, what setup looks like, what changeover looks like, anything that you can think of that would be traditional to an automation application typically translates over to machine vision as well. All right, what do we got? Number four?
Number four is AI versus machine vision.
Oh, so awesome topic. Okay, so we're doing a lot more AI now. So I've been doing machine vision for over 20 years, which makes me sound old because I am. But when I used to go into clients, they would say, this is good, anything else is bad. And you would say to them, with traditional machine vision tools, that's not really entirely how it works, or maybe not at all. You have regions of interest, and you have parameters, and you have tools that you apply, and then you have thresholds that you apply within those tools. So, you had to set a lot of different characteristics and tools and parameters around, any one inspection. AI sort of leveled the field a little bit, where it's more on the side of that, this is good and everything else is bad, or more specifically, this group of things is good and this group of things is bad. So if you think about machine vision, what you're really trying to do when you're writing your specification and you're deploying a system that's going to be successful is you're trying to make sure that you have a clean divide between what you consider to be non-conforming products and what you consider to be normally occurring deviation in your manufacturing process. So if you think of those as two curves, you kind of want, and this is how some AI tools work when you set them up as well, but you kind of want this valley in between. It's this very clear divide between things that maybe are can be appear to be anomalous, but at least are still good, and things that are very clearly bad. And then with AI, what's nice about that is really the AI is doing the work, right? So some traditional vision people say, I don't like AI because I don't know what it's doing. I can't pull as many levers, to make it work or not work. So I think that comes down to, are you using it for the right application? So those applications that would be considered to be more on the side of subjective, and maybe you're looking at products that are a little bit more organic in nature, are great for AI. So even things like label inspection, where you have small defects and scuffs and things that would be considered cosmetic. AI is really, really good at those things. If you're doing high precision dimensional measurements, that's probably more on the side of traditional machine vision. So, I think it's still kind of right tool for the right job. But what AI brings is, the strength of the algorithm and the strength of the model, and the fact that as you feed it more information, as long as you're feeding it good information, it'll actually become a much stronger tool than the way that you started. So to that point, when we're doing deployments, traditional machine vision, you can say, here's your parameters, here's your failure modes. We're going to run X amount of products as part of the SAT to validate the system, and then we're good. And then you release it into the wild, and you set forth how you want to maintain that system. AI, I think it's important when you're purchasing AI from an integrator that you understand that there's a lot of times that the first deployment is not representative of what the final system will be. And the reason why is, based on what I just said, the more information that you can give it, and the more variety of your normally occurring deviation, and then partitioning those off into good and bad, the stronger the unit becomes, right? So yes, there are less levers to pull, but intentionally so. So as you feed it better and more information, the unit is going to get stronger. So know that your AI deployment is probably going to be, partitioned off into kind of comebacks from your vendor to update the model and do that over, say, a 90 or 120-day period until it's exactly what you want it to be. So a little bit longer process with AI vision as well. What's next?
Number 5 is how to evaluate a machine vision provider.
Yeah, this is a big one. Obviously, we're a little bit of a biased party, but I've been on both sides of this. So I work for a machine vision component manufacturer, and really that was my entree into owning machine vision integration company. So I think let's talk about what is most underrated in terms of a good machine vision deployment, and that's the mechanical setup. So a lot of machine vision integrators and programmers, they're more keyboard bangers. They're not, they're not automation houses. So, if you're wanting to pick a good machine vision integrator, make sure they have strong mechanical competencies and strong electrical and strong automation competencies. Make sure they know how to take that system and integrate it, into your line upstream and downstream, so it's not actually causing more problems. Some of the, one of our kind of value propositions to our clients, in addition to those things, is our ability to do data analysis. Because if you're doing machine vision and all you're doing is kicking off non-conforming parts, yes, you're mitigating risk and brand integrity threats and non-conforming product and now recalls and all those things, but you're still creating scrap. So where we always take it is, well, let's give you the information and the conditions that are present in the equipment when faults are happening, so you can actually go back and resolve that issue. But to that point, as far as AI versus traditional vision, and this is a huge one, what AI brings to the table is classification. So maybe above all other things, it's not that there is a defect, it's what is that defect. So for example, if you were looking in a particular container and there was a a washer or a snap ring or a fly in the bottom of the container, traditional machine vision would say there is something there, right? AI, as long as it's taught properly, will give you that delineation between what those are, and maybe not the best example, but I think is you think about the power of classification, is you understand what your defects are, where they're occurring, and then you attach that to the information in the machine at that time. Now you're doing root cause analysis, and you have a very specific cause and effect, as opposed to saying, in this region there's a problem, in this donut there's a problem, on occasion there's a problem. But what you can say, it's this very specific type of defect that I have identified and I know what to do about. If we can flag those things, feed that information to our clients, and empower them to be able to make change, again, that's going back to being a much stronger production tool. So, as you're picking your partner, make sure they have good automation competencies, and make sure they're a good, solid mechanical design firm, and still have the fundamentals of, electrical, controls, and then they're able to program and support the equipment. A lot of times vision is an iterative thing. It's not always out of the gates exactly what you need it to be, because as your product changes and grows and your the brand marketing and things that are going to change, you might need to change your vision equipment accordingly. So you want to make sure you have a good partner that's going to come with you along the way and be able to support your equipment. What do you got next?
Number 6 is how to acquire a proposal.
So, yeah, this is great. So this also is another, I think, evaluation point of your potential provider of equipment. Is if someone looks at an application and is very quick to give you a proposal. So here it's it's a ring light and a camera, and it's this and that, and here's what it is. You're going to want to be naturally apprehensive, because the firms that are a little more needy per se, or a little bit more diligent to say, I really need to see your written specification. I need to be able to collect samples from you. I might want to do an online study on your line to actually prove that what we're doing will work. Those are the people that you want to align with. And then once you've decided, who you want to align with, make sure that they're doing a site survey and they're getting to your facility, because it doesn't come across in pictures and videos. I don't care how good pictures and videos you take. There's something about being on the floor, looking around 360, understanding the environment, see what operators are doing, see what machines are upstream and downstream. That all matters. So make sure they get to your facility. Make sure you have that written requirements document that we talked about a little bit earlier today, because not written, not said. So it's not that anyone would do anything with malintent, but ultimately the provider and the end user need to be able to hold each other accountable to what was purchased and ultimately what was delivered. So you've done the visit, you've given consideration to site surveys and testing, you've provided a written requirements document. I think it's also important to give a realistic budget to machine vision. I think sometimes people work cameras out, and it's kind of more system in terms of really taking into account all the other things, because for us, when we deploy a machine vision system, the camera may only comprise 15 or 20% of the cost of the entire system, because it really just becomes one cog in the wheel of the deployment. So have a realistic budget, and then provide that to your trusted integration partners, and let them give you a proposal. And then talk. We see this a lot, where I think there's still a thought that automation is very transactional. Here's your requirement, here's your proposal, and it's a pass or a fail. That really is just the starting point. That really should be a kickoff of really good dialogue to say, did we understand your requirements document right? And also, you should require that your integration partner is very informative on maybe what's driving up price artificially. So we say this a lot to people. If the requirement is 100%, it is kind of the 80-20 rule, where that maybe that last 20% is really driving up the price considerably. So as you think about your requirements in terms of like what recipes and what products are included, think about how important those really are, because by including some of the outliers in your process, you might artificially drive up the price of the system, and you're getting away from the fundamental reason why you're deploying that system in the first place. So have a really good dialogue with your vendor. Make sure you're understanding where all the pricing is coming from, what are some things that are maybe artificially, driving the price, and then have a healthy negotiation and settle into something that both parties can be happy with and move forward with.
Evaluating a good design in machine vision.
Okay, good. So good designs in machine vision are quite similar to good designs in automation in general. So first is taking into consideration the environment in which you're designing in. So if it's washed down, what materials are you able to use, making sure that there's no penetrations in the food environment, for example, where bacteria can be collected, make sure that everything is going to be sealed, especially when you're dealing with, cameras and lights and things that are, sensitive, obviously, to water and that type of thing. I think also the adjustability is probably the biggest part of a good mechanical design. The least amount of adjustment possible makes for the most robust machine vision deployment. So, we have people come to us a lot and they say, well, I have different heights and diameters and whatever it is. And can you just have the camera move depending on what's going on? And it's not that it can't work, it just usually doesn't, because you're now dependent on whoever's interfacing with that system, that's usually not necessarily a technical person, kind of making those adjustments. And again, it's not to say that it can't happen, but it's so much better if you just take into account, all of the parts of the scope of that particular system, design the mechanicals around it so it doesn't have to be adjusted and you're just doing recipe selection on a screen. That by far is the best way to go. So if you see a design or a concept or something that you're looking to improve and you're seeing slots and adjustments and tilts and all these different things, do your best. Sometimes it's just necessary, right? But do your best to mitigate as much as you possibly can in terms of adjustment with your machine vision design. And then I would say the last big thing is shrouding. So when you think of traditional automation, obviously there's access points and there's doors and things like that, but you want to be intentionally protective of a vision application. So you want to make sure that you've got good solid shrouding, whether it's a tinted polycarbonate or it's a stainless steel shroud or whatever it is. You want to protect that system, have it be a little bit black box in terms of mechanical access to the equipment as best as you can. And what that helps with is those weird environmental factors. There's flashing lights somewhere, there's sunlight coming in, or whatever it might be. So make sure you're environmentally appropriate. Make sure that you don't have a whole bunch of adjustment in your system, and then make sure that you're protecting it as best as you possibly can. Otherwise, I would say it's probably kind of more commonplace good automation practices. What's next?
Thinking about the programming.
So keep it simple. I think whenever you're doing or considering deploying a machine vision application, you look at a product and you put it in front of enough people and they say, well, I need to do this and we need to do that and now we need to see this. And our first question is, why? Why do you need to do that? So what we try to work with our clients on is let's partition off your wants list and your needs list. And your needs list are known defects, known root causes of customer complaints and consumer complaints. So let's start with that and then let's build our way up. What people say a lot is, well, let's do everything and then we can take things back out. The problem with that is it sort of sets you up for failure because you're starting with the most complicated version of a system and then trying to pull things out, which is it's fundamentally different than any approach to any other engineering issue you would take. You would say, okay, what's my minimum viable solution to satisfy the requirement? Let's get that to be super robust, and then let's build on it from there. So when you think about your software architecture in terms of your vision program, think about making sure that you're starting with the fundamental requirements and then give consideration to building up from there. Again, balancing how many things are you trying to inspect for versus what is the scrap implication of those particular things. So I would say that that's the most important from a vision programming perspective. From a controls perspective, don't skimp out on, having an onboard PLC. It's always beneficial, upstream and downstream communications, dealing with rejects, helping in data collection. So thinking about your electrical architecture in general, you want to make sure you're going to have your smart camera or something that's PC based. You're going to have, your PLC, which is going to be talking to your sensors and your reject system and things like that. And then you'll have your vision program doing all the recipe control and management. So again, keep it simple, give yourself some flexibility, make sure you have all the core components of, again, a small automation system. And that is usually a good jumping off point for a pretty solid software and controls architecture.
Good. Okay,
What else you
so
got?
just wrapping it up here, talking about more than just an inspection, how can users leverage data to get better?
Yeah, you bet. So I touched on this a little bit earlier today. So where we're taking our clients to is, AI has now afforded us the opportunity to do the classification that I mentioned a little bit earlier. So with that classification, if you, and back to having a PLC on board and having a PC or some other intelligences, if you're talking to the machine and you've chosen a vendor that knows controls and knows vision and knows data collection and knows OE and all the things that are important to tie this all together, what we want to do, for example, is we want to classify your defects. We want to identify when they're happening, and then we want to correlate back to conditions in the machine to figure out why they're happening, because why is what we're trying to get to. So is it a combination of raw materials? Is it a particular recipe? Is it a product that you're filling? Is it an amount that you're filling? Is it, in the case of, say, like a sealing application, is your sealing head maybe a little too hot or too cold? So, that's the power there, I think, of kind of a re-excitement about machine vision in the industry. Is now it's not just this thing that kicks off bad products. Now it's a data collection mechanism. So, our hope is when we deploy a vision system is that the inspection actually becomes the smallest part of that in terms of the value that it brings. For us, that is a mechanism by which we can harvest information and then tie it back into other parts of our customer's process to make sure that we can actually solve their problems instead of just rejecting a product that's not.
Okay, so just wrapping it up here, the very last question is if we can just give an overview of the fundamentals of a good machine vision deployment.
Yeah, okay. So that could be a 20-minute video unto itself. But so as far as the deployment, so let's go back to where we started. We've got a good requirement. We've picked a good vendor. We've done the proper testing. We've evaluated a good design, and we've gotten to the deployment. So, be fair to your vendor. If you want them to inspect for these defects on this variety of products, you have to have those defects in those variety of products available to them. And you have to have them available at quantity. So making sure that you've got a realistic amount of time, downtime, right, is obviously a key. So you want to land the system and get it electrically sound, do some testing, do some manual pass-throughs of product and make sure that it works. That's part of it. And then now your uptime or partial uptime while testing. So the reason that's really important to think about is that depending on what your product is, there's a good chance that whether it's AI or traditional machine vision, you have to cycle a lot of products through the system. And which means you might have to scrap those products, again, depending on your process, or those might be saleable products depending on what you're looking for and what you're producing. So be mindful of the fact that you need to provide your partner with enough time downtime, enough time uptime with testing, and then enough follow-up time, I would say, to continue to make adjustments as necessary before calling the system good. Hands down, the quickest way to fail is to hurry up, deploy a system, do it on limited information, limited testing. Your vendor does just enough where they can get you to sign off and says it looks like it works, and then everybody leaves and the plant is left with a disaster because they don't know how to use it. It hasn't been properly tested. They may or may not have wanted it in the first place, depending on how the application originated. So, making sure that you have the appropriate amount of time to do all the things, and then the very last part of that is adoption and training. So, if you want the plant to love it, just like any other piece of automation, you have to account for training. It's an automated device. You have to train people. So, think about, you've already done your commissioning, you've already done your SAT. You've likely already done some degree of hypercare where you're just tending to the system and kind of making tweaks and adjustments as possible. Make sure that you're accounting for training, and that's going to help with your adoption. So if you've done all those things, you get to a good adoption. You've trained the team on how to interface with it, and hopefully they don't have to interface with it much, maybe just recipe selection. That's the ending of a really good vision deployment that started in topic 1 today. So I think that's it. Sorry, I yammered a lot. I love machine vision. We love to talk about it. If anyone has any questions, you're welcome to reach out to me directly. We've got an awesome team here. We've been doing machine vision for 10 years, and I've been doing it myself for over 20. So if you have an application that you'd like to discuss, please. If you're another integration partner and you just want to talk shop a little bit and compare notes, great as well. And if you're an end user that just wants some advice on how to go find a good partner, I'd love to hear from you. So thanks for the time today.